Hello, my name is Ezan, and I'm a developer relation engineer in the Android team working on machine learning. Earlier last year, we announced the TensorFlow Lite with Google Play Services in beta. And in September, we released the stable version. Fast forward to today, TensorFlow Lite in Google Play Services is used by thousands of apps and more than 1 billion users monthly. You will still be able to bundle TensorFlow Lite with your Android application if your user's device doesn't have Google Play. But moving forward, TensorFlow Lite with Google Play Services is Android's official machine learning inference engine. It will let you easily integrate with the future APIs and services from the Android custom ML stack, as they will be built on top of it. Google Play Services will take care of providing the latest version of TensorFlow Lite to your application, so you won't have to bundle it. In addition to saving several megabytes, actually up to 5 megabytes if you are using the GPU delegate for hardware acceleration. This will enable your app to benefit from runtime optimizations and bug fixes as they become available without any changes to your code. Okay, let's see how to add the interpreter API to your application. In this video, we will focus on the interpreter API for Java and Kotlin. But keep in mind that you can also use the native interpreter API using C or C++. But as of now, the native API is only supported in the bundled version of TensorFlow Lite. Start by adding new dependencies. Add the new Play Services TensorFlow Lite import to the build.gradle file of your app. Optionally, you can also add the TensorFlow Lite support library, which provides utility methods and data structures, helping you with data processing and data conversion. If you are already using TensorFlow Lite, you should replace your existing TensorFlow Lite dependencies. Then, in your Kotlin code, create a task to initialize your TensorFlow Lite runtime. Here, the task class is the same API you may have already met in other Google Play Services integrations. A task lets you make asynchronous method calls. You should then add the onSuccess listener to the initialize task that will create your interpreter once TensorFlow Lite runtime is initialized. Once the initialization is successful, create an interpreter API.options object and specify that you want to use the TensorFlow Lite with Google Play Services runtime by passing from system only. Then create your interpreter by calling interpreter API.create and by passing your TensorFlow Lite model and your options. If you are already using TensorFlow Lite with the interpreter API in your Android application, you'll notice that we use the interpreter API class. The interpreter class, still used in the bundled version of TensorFlow Lite, will be deprecated, and implementations using the bundled version can already use the interpreter API class. You can see here that we are using the Google Play Services Task API for asynchronous method calls. The tasks are a key to Google Play Services APIs. You can learn more about it in the Google Play Services documentation. What you have seen so far enables you to run inference on device with TensorFlow Lite with Google Play Services using the device CPU. But running the CPU isn't always enough to enable a low latency and high accuracy. Delegates enable hardware acceleration of TensorFlow Lite models by leveraging on-device accelerators, such as GPU chips or graphical processing units. Often, a GPU, which is a chip designed to handle graphical rendering, enables better ML inference performances. So let's see how to take advantage of it. First, update your app's dependency to import GPU delegate dependency for TensorFlow Lite with Google Play Services. To run inference with the GPU, you need to ensure that the device your app is currently running on has a GPU that is compatible with the TensorFlow Lite GPU delegate. Once TensorFlow Lite is initialized, you can verify the availability of the GPU delegate by running the task provided by isGPUDelegateAvailable. Then, launch the task asynchronously by calling continue with, and in the callback, check the task results to confirm if a GPU delegate is present. If a GPU delegate is available for your device, add it to the interpreter API options by calling addDelegateFactory and passing a GPU delegate factory object. Keep in mind that the GPU delegate isn't supported on emulators, even if you created an emulator with the hardware graphics rendering enabled. The Android ML team is dedicated to make TensorFlow Lite with Google Play Services the best platform to deploy on-device machine learning on Android. And we are working on more tools and solutions to let you build great machine learning features on Android. For example, we are building an on-device functionality that will let you identify the optimal acceleration hardware for your model between CPU, GPU, DSP, digital signal processor, or NPU, neural processing unit. We are also working on making the delegates and drivers updatable so your model is always running on the latest and greatest without any changes on your end. It is still early, but if you are interested in testing out this API, go to the early access page on the machine learning section of developer.android.com. You can learn more about TensorFlow Lite in the Google Play services by visiting the TensorFlow documentation page. And you can share feedback through the TensorFlow GitHub project. We can't wait to see what you are going to build with it. Thank you for watching.